Okay, so when all three sides of a triangle are known, the law of cosines is our only hope for solving for a non-right triangle. Yeah, we must remember that not all side combinations are possible. So we may have a side-side-side combination where it's just not going to work. Like the sides are just not going to fit together. So let's try this one. So it's going to have a 2, a 3, and a 7. So what we need to figure out is if 7 is a long enough thing to connect between those 2's and those 3's or not, if I can build this triangle with those 2, 3's, and 7's. Okay, so let's give these sides some names. They've already been named a little bit for us. P is 2, so this is capital P. D was 3, so that's capital D. Q was 7, so this is capital Q. Okay, and so let's start by finding your choice of angle. Let's try to find angle, how about Q first, just for something to find first. All right, so we'll start with side Q, which is 7. So it'd be 7 squared equals 2 squared plus 3 squared minus 2 times 3 times cosine of angle Q. So I'm looking for the angle now. And so on the other side of the equation, I need the corresponding side. Okay, so let's simplify our numbers. So that 7 squared is, of course, 49. And then our 2 squared 4 plus our 3 squared 9 is 13 minus 2 times 2 times 3, which is 12, cosine Q. Okay, so if I subtract the 13 over, 49 minus 13 is 36, just subtracting that over, equals negative 12 cosine Q. And then if I divide by 12, we get negative 12. I get negative 3 equals cosine Q. And so I can see that right here, this triangle is not possible because this is too big. Remember, cosine has to be between negative 1 and 1. This is it's too large negative, so I don't want to say too big or too small, but it's too big for cosine. It would need to be between negative 1 and 1, so this triangle is not possible to solve. So it means that you cannot connect a side of 2 and 3 inches with a side of 7 inches. Just not possible. The side is too long, or it's just not going to work. There's no possible angle combination that's going to work. So let's try it again in the next one. Okay, so this one I have a side A that's 11.2, a side B that's 5.4, and a side C that's 7. We're going to find out, is it possible to connect these sides? Okay, so A was 11.2, so that's angle A. B, so this is angle B. C, so this is angle C. Okay, and again, it doesn't matter which side I solve for first. Let's go for B. I'm just picking one at random here just to solve for first. Okay, that's going to put our 5.4 squared equal to our, so B, opposite of B, and then our 11.2 squared plus 7 squared minus our 2 times AC, so 2 times 11.2 times 7 times the cosine of B. Okay, so first of all, 5.4 squared, that's 29.16. And then if I add up 11.2 squared plus 7 squared, this whole sum right here, 11.2 squared plus 7 squared, is 174.44 minus 2 times 11.2 times 7 is minus 156.8 cosine B. We're going to subtract the 174 over, subtract it over, so our 29.16 minus our 174.44 subtracts over to negative 145.28 equals that negative 156.8 cosine B. Now divide this off, so divide both sides by negative 156.8, gives us 0.92653 equals cosine B. Now, we are in much better shape because this value is between -1 and 1, so we're able to arc cosine both sides. So if we take the arc cosine of 0.92653, if we're in degree mode, it's going to give us our B value. And so I get, using the arc cosine button on the calculator or typing in decimals, I get 22.0997 degrees for B. Okay, now there are two possibilities. That's one of them. So cosine can, if the cosine value is positive, it can return two different angles. And so the other angle where cosine is positive is in quadrant 4. And so since I would need to wrap into quadrant 4 and either use a negative angle, triangles don't have negative angles, or an angle bigger than 180 degrees, we're not going to get a second angle for a positive cosine value right here. So we only have one choice that comes out of our law of cosines, the 22 degrees. Okay, so I know that that's B now. I have my B value at 22.0997 degrees. The other possibility is not actually possible. And so now if I fill that in over here, now if I have my 22.0997 as that angle, I have that pair, so I can use the law of sines to find one of my other angles. So let's just say we're going to go ahead and find C first. Doesn't matter which one we find first, but I can use subtraction to find the third. So if we now use law of sines, if we go back and number our steps, we had our law of cosines. And we did that first, and then our law of sines we're going to do second. And so we would say sine C over side C, which is 7, equals sine B, which is our 22.0997, divided by side B, which is 5.4. So if we just multiply both sides by 7, okay, then we can do the sine of that 22, etc., divided by 5.4, then times 7. And that gives me a sine ratio for C of 0.48769. And if we use the arcsine feature there to find C, that gives us the C value of 29.1889. So it's 8898. So I'm going to have to round this a little sooner to 0.189. And remember, for sine, we're looking at top two quadrants where it's positive, and so I do need to find the other angle since it is inside the 180 degrees. So if I subtract 180 minus that angle, say we're 29 degrees shy of the 180 mark, that would have been a possible angle of 150.811. Okay, so our angle C, since it does not have the largest side across from it, cannot be the largest angle, in which case we're going to have to throw away the 150 because it is too large for C. The side A right here is going to be the larger angle. Had we done A first, we would have had to throw away the small one and go for the large one. Okay, so we did C first, we're throwing away the large one. Okay, so that's two things that we know. This is again a degree angle. And so our third thing we just need is angle A. And so now if we take 180 minus the, hold on, just getting my calculator ready, minus the 22.0997 minus the 29.189. If I subtract both of those somewhere, I think I'll have space maybe up here for the third step. So our angle A comes out as, so 180 minus 22.0997 minus the 29.189 equals 128.711 for our angle. And that is the last thing that we needed to find. And so now we have angle A, B, and C. Okay, and they all worked. All right, cool. So sometimes if I just know sides, it's not possible to solve it. Sometimes it is possible to solve it. I did get 2 values for this one. One of them did not make sense, and so I ended up with one possible solution to this triangle. All right, so a quick summary here at the end before we finish this section. We have several types of triangles that it's possible to solve. So one of the types is side, 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 like we just saw. So if I know side, 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 we need a law of cosines and law of sines eventually. You really can't use law of cosines by itself. I'm just going to write down the first law that we're going to use. It's going to be cosines. Okay. If instead we had, let's see, 2 sides and the angle that was between them. So this would be side, angle, side. If I don't have a ratio of those, that's going to be cosines again. Okay. Other scenarios would be if I had 2 sides and an angle that was outside of them. So side, side, angle. And so this one, since I have a pair, this one would be law of sines. Okay. The other things I could have would be 1 side and 2 angles. So angle, side, angle. And I could do sines with this. After I solve for the other side, I could use sines right there. Or I could have side, angle, angle. So that would be angle, angle, side. And I could use sines for that one as well. Okay. I think that's all of the pairs that are possible. The other situation that I can think of, so I've done, I know 2 angles and I've done 2 angles on one side, and you can either have the side between them or not, and you can have 2 sides and 1 angle, it's either between them or not, and then you could have something where you knew all of the angles, and then this one you can't solve. So none of them can be used. So those are our possibilities and then what we can do to solve them.